So welcome to the Melbourne Connect and Melbourne School of Psychological Sciences event, Understanding 2020, The Science of Music. This features Professor Sarah Wilson, who's the head of the Melbourne School of Psychological Sciences, and we're stoked to have you involved today, Sarah. Before we begin, and for those attending today, we'd like to acknowledge the traditional owners of the land we're on today, the Wurundjeri people of the Kulin Nation, as well as obviously the traditional owners of the land that you yourselves are situated on, and acknowledge that Indigenous Australians have been custodians of the lands and waterways of this country that we call Australia for thousands of years. So we pay our respects to their elders, past, present and emerging. And we're very thankful for you coming along today to this event. My name is Garry Williams and I'm the creative producer of innovation at Melbourne Connect, which is a part of University of Melbourne. We're delivering this Understanding 2020 event for you here today. The event series, as I just mentioned before, it's a collaboration between Melbourne Connect and the Melbourne School of Psychological Sciences, and more on the school very shortly. These fortnightly online events are designed to delve into a range of topics focused on very current and relevant topics, with evidence-based research and leading psychologists driving the very thought-provoking and relevant discussions. So I'll show some slides which will give a bit of context behind what Melbourne Connect is, as well as do Sarah the service of talking about her background and research before she leaps into her presentation. Just let me share my screen here. It won't be 1 second. So there we are. So we're here for the Science of Music. And as you can see pictured on your screen is Melbourne Connect. It's a forthcoming innovation precinct launching at the start of 2021. We're really excited to have it launched, and it'll give a great opportunity for us to gather once again. Located in the precinct shall be the Melbourne School of Engineering, Science Gallery Melbourne, Complex Human Data Hub, Centre for AI and Digital Ethics, Melbourne Accelerator Program, and much, much more. We'll have a Fab Lab, Makerspace, and of course, event and gathering spaces for conversations exactly like these. We're really excited to have it come to fruition, and it's progressing very steadily. And of course, this unique precinct will contribute to, this city and country's immersive culture of entrepreneurship. So we're really excited to unveil it in due course. Here's some renders and examples of how we'll gather in the future in this custom, or should I say purpose-built precinct. So we're here for the Science of Music today, and we've got Professor Sarah Wilson. Sarah, I'll do the formal service of talking a bit about your background and what you've been involved with first, and then we'll launch into your discussion. So Professor Sarah Wilson is the head of the school at Melbourne School of Psychological Sciences. She's an internationally recognised expert in cognitive neuroscience and clinical neuropsychology. Her research program has advanced our understanding of the neural basis of human cognition and behaviour. And she's pioneered music neuroscience research in Australia, showing how music can enhance brain function in healthy individuals and facilitate recovery after brain injury. Sarah employs behavioural, genetic and neuroimaging techniques in her research and heads a vibrant team in the clinical and music neuroscience lab. Fantastic. We'll also touch on this part a little later. She's the Director of Music, Mind and Wellbeing, which is a world-first initiative linking neuroscience with music and social wellbeing through a unique set of collaborations spanning music, science, health, and much more. So really exciting, and I'm slightly out of breath, Sarah, but I'm really excited for your presentation. And I know you've presented on a number of these topics before. We're bringing together a wide and diverse group of people, both from an academic and also industry background, to head along today, participate and hear from some of your groundbreaking research. So we're really excited, and I'll let you talk now and take a beat.
Yeah, thanks very much.
Look, it's great to have you. I'll do one last bit of housekeeping. We're going to go to 1:30 today. Sarah mentioned just before, so she's essentially going to present for about 15 to 20 minutes, and then we'll have questions which you're welcome to pose towards Sarah, which I'll curate. You can do so in the Q&A function at the bottom of your screen, or the chat function, whichever you prefer. I'll curate those towards Sarah as well. And last bit, we are recording this event and we do publish on a YouTube channel. So if you miss any points of it, it will be available a little later within a few days. So Sarah, over to you. Thank you so much for being involved today. And I'll probably disappear into the background for now and leave you to it.
All right. Thanks so much, Garry. And I think this is a fabulous initiative between our school and Melbourne Connect, and we're really excited that part of our school is going to be housed in Melbourne Connect. Garry mentioned the Complex Human Data Hub, and we're really looking forward to all of the opportunities that will bring and the links that will be able to generate with new partners and engage in exciting new research and public-focused activities. So today I'm charged with the job of just giving you a bit of an overview of the science of music, and I show my bias here. I've inserted the word neuro in front of science because as Garry mentioned, that's my background. I did my PhD in the neuroscience of music, and I've continued to work in that field ever since, and I have a strong lab in the School of Psychological Sciences, the Clinical and Music Neuroscience Lab. Now, there's a lot that I could potentially cover in this talk, and I want to keep it fairly high level and succinct. So what I thought I would do is just summarise for you what are the core now well-established findings that we know about music and the benefits of music for the brain in the general healthy population. I could also focus on for people with brain injury, but that's a separate talk for a separate day. So when we think about music, it plays a very important role for many of us in our lives, and often captures those emotions and moments that are hard to put into words, and brings us together as a community in unexpected and important ways. And I think COVID-19 is no exception to this. And I've got just a little link here to show you in our very own Melbourne northeastern suburbs, just natural use of music arising in the community. And I'm just going to share this little video clip, which I just think is delightful. This is just filmed locally. Some music opera students taking to their balconies in northeast Melbourne and putting on shows. This was as part of the first phase 3 lockdown. And locals would apparently bring their deck chairs and their wine and cheese and sit down below and listen to these beautiful performances. We also saw in Italy a lot of balcony singing, a way that people in really hard lockdown can connect to each other even though we're socially separated. And you can see how much fun these students are having in doing their performances. A fantastic note to end on in that performance. So that's just one example to show you how music comes to play in different circumstances and how we draw on it as it's an intrinsically hardwired human ability that we think is really quite unique to humans. We don't see the use of music in other species as we do in our own. So I'm just going to now show you the brain singing. So you heard those students doing some beautiful opera singing, and here's an fMRI image of what the brain looks like when we put people in the scanner and we ask them to sing. And what you can see is that it's a bilateral activity of the brain. It involves both hemispheres, and the networks that are activated are quite broadly distributed. And so this is quite different to something like language, where it's much more one hemisphere mediated and perhaps less distributed. And we think this brings some very important benefits to music. And a core of one of those benefits is this concept of neuroplasticity. So the research literature that's been done has spent a lot of time documenting how music, when we engage in it regularly, when we practice it, when we play it, how it changes our brain systematically and brings a whole host of benefits for our thinking. And that's what I wanted to do today, was to talk about those and to summarise those key findings. But this body of literature is so strong now that, in fact, music has almost been dubbed the food of neuroscience. We've learned so much about the brain from our study of music. And here's a great quote, I think, that captures that playing, listening to and creating music involves a tantalising mix of practically every human cognitive function. So by looking at music, we're looking at all of these different functions that make up the act of music making, and we learn a lot about the brain and the science behind that. So the core idea is that music making is a complex skill, and it integrates, in the act of doing it, it integrates multiple brain systems. It's a whole of brain activity, and that's what brings it its benefits. And the kind of findings that I'm pulling together are from over 100 neuroimaging studies that have now been done in the field looking at this. And these are, if you like, the more solid or core findings. So the first thing that we see in terms of the benefits is that regular engagement has an impact on our sensory processing, and that musicians tend to have more highly developed sensory processing as a function of regularly engaging in music. And we might think, well, that's obvious. It relates to auditory processing because they're dealing with sound. And certainly we see that there's this area of primary auditory cortex, and this area of the cortex gets larger and enhanced in musicians. For instance, they've done studies with people who play the piano, pianists, and the cells or the representation of piano tones is anywhere up to 25% larger. But you can see it's specific too. It's specific just to piano tones. So the brain really does adapt and respond to the input that it's dealing with. And this has been kind of dubbed the pitch centre or area in the brain, important for this. But it's not limited to that. It also extends to visual areas at the back of the brain, to tactile, sensory tactile, and kinesthetic movement-based improvements in processing, because when we're playing music and engaging in it, of course, we're using all of those different sensory processes. In terms of pitch, though, which is a core one in music, processing the pitch or the actual getting the note spot on, hitting the target, we know that there's these key structures in the brain, in these sensory and auditory areas. And here's a side-on view of that, like I just showed you. This is the front and the back of the brain. But then if we take this slice all the way through and we look down on top of the brain and we take this section this way, we can see here the planum temporale. And this is where we see quite noticeable differences in the brains of musicians and non-musicians within enlargement of these areas, and in particular in musicians with a rare skill known as absolute pitch. And this change brings benefits for fine-grained pitch perception, which is important not just for music, but also speech and sound processing and auditory streaming, as we call it. So the auditory soundscape, we have to parcellate into its different bits and stream those and process the syntax, the way that changes over time. And again, engaging in music has significant benefits for that. So here we are just talking about these centres that are advantaged by these skills involved both for speech and music. Another area is in the motor systems of the brain. So when we're playing an instrument, obviously we've got a lot of fine motor skill learning, which is high-level coordination by manual coordination between the two hands or body parts. If you're an organist, it might be your feet as well, or if you're a percussionist, a drummer. Or if you're a singer, it'll be enhancement of vocal control regions. And on the brain, we have this homunculus, which is the map of the human. And as you can see, it doesn't look like a normal human. The hand regions get a lot more representation, and the lips, the areas that have a lot of neurons dedicated to their functions, where we are engaged in fine motor control like speech and manual tasks. And in musicians, we see enhancement even above what we see in non-musicians. A very cool study, for example, took the MRIs of pianists versus non-pianists, and you could judge just by visually inspecting the scans who the piano players were by the size of the hand region on their motor homunculus. In trumpeters, the lip region is shown to be enlarged. In vocalists, it's the vocal cords. And in violinists, it's the fingers, but specifically the fingers on the left hand. So you can see the brain adapting this concept of neuroplasticity in response to training and playing music. And then, of course, there's the integration of those two things, the sensory and the motor, because as we play and perform, of course, we're listening to what we're doing and we're monitoring it and we're correcting it and altering those motor programs as we go. And so this integration process is also, there are benefits for that. There's enhancement in musicians. So those are the obvious things. Well, they're what they're doing every day, so we might expect those things to be enhanced. But then there are also these transfer effects where other cognitive skills, there are benefits for them, even though it's not intrinsically obvious that the music is requiring those things. But when we take a closer look, we find out that it is. And another area of the literature has really highlighted that music enhances our higher order planning and what we call executive functions, our control functions, directing the traffic of the networks in the brain and bringing our attention to bear on a particular issue or function, as well as holding those things in mind and then using them creatively to solve problems. And music has benefits for this. And here's a study that highlights these additional working memory areas that are activated. Here's someone in the scanner listening to music, and we see those sensory, auditory areas lighting up. This is looking at the brain top down, and this is looking face on. But then when we even get someone to imagine they're listening to music, we'll see additional activation of these working memory areas, which are important for holding things in mind when we're attending and planning. Now, we spoke, as I introduced the talk, about the importance of music being the language of emotions and expressing those things that we feel that are hard to put into words. And most of us will engage in music listening because it has this direct line in to the reward network of the brain. It's one of these few cognitive activities that in fact can have this direct line in. And it's no coincidence that when we think about sex, drugs and rock and roll, those three things go together because they all have this direct line into the reward or pleasure centres of the brain. And there's been now very nice neuroimaging work showing that we activate the peak pleasure area, the nucleus accumbens. This is this complex reward network, and this certainly shows activation when people report chills in the scanner when they're listening to their favourite pieces, or those highs that music brings. But there's also other areas of the brain that activate in anticipation of that. And you can chart this in real time in people's brains and show the build-up and then the peak pleasure response. And it's this direct activation of the reward network that we believe makes music such a powerful mediator and a motivator that we can use in our everyday life, and that can bring benefits to our mental health and that can connect us with others. The other thing that it can enhance for us is our memories. And this is really evident, I think, in some populations, for instance, like people with dementia, where they may be pretty much shut down in terms of many of their cognitive functions, their memory's not working well, their verbal skills may be almost gone, and yet we'll put on a piece of music from their teenage years and they will light up and engage. And so this is a form of memory that we refer to as autobiographical memory, and music seems to hook into that and be core to our identity and our sense of self, and is a strong and powerful memory aid. So over here I've got a picture of what is the normal memory system that we think about. For instance, if I'm studying for an exam and I've got to learn a list of words, I'm using this declarative memory and I'm bringing to bear on it my semantic knowledge of the world. I'm holding the list or the information in mind, and I'm using neocortical structures in the frontal regions and the temporal regions to help me do that. But there's another part of our memory system which is buried more deeply inside the brain, in the temporal lobes, in the middle of the brain, and it's encoding all these day-to-day events that happen to us. And a lot of that is implicit, and it's often linked with emotion. And we acquire that effortlessly. And if you think about musical memory, a song from your teenage years comes to mind, and without even realising it, you can still remember all of the lyrics, despite the fact that you haven't practiced that for years. And of course, the same isn't true, sadly, of all the things we learnt at university. But what we think's going on here is that the emotional power of the activation is implicitly helping us encode important episodes in our life in terms of time and place and emotional tone, and that gets linked to the music and allows us to reactivate it and retain that memory trace. So in growing up, that's why the music of our youth becomes core to our sense of self and our identity, because it's forming part of this trace that we lay down over time. And then a more recent area of research in the literature is looking at the benefits of music socially. And I've had one student recently finish a PhD in this area, and another one just starting recently. So this is an exciting area where we're beginning to understand, if you like, the survival value or the evolutionary significance of music. Why do we have it? You know, Steven Pinker called it auditory cheesecake. It served no function, but we don't really agree with that. And this research is beginning to show that when we engage in music, and in my PhD student study, James Richmond is his name, he did drumming, either imitative drumming or synchronized drumming, and showed that when you do that with another individual versus if you just drum the same thing with a computer track, for instance, that you'll be much more likely to help that person, that it will increase your empathy and your social cognition towards that person. And so this is kind of at the heart of how music might enhance social groups and social bonding, because it activates this social cognitive network within the brain as well. So that's a bit of a cook's tour of music in the brain and the science that sits beneath that. All of the different systems that we've touched on are at play, all in the one act of engaging in music. Our auditory cortex, our visual cortex, our sensory, kinesthetic and bodily awareness, these association areas that sit between the sensory areas that link it together, our motor cortex when we're responding and playing, this area down the bottom here, which we haven't talked about, the cerebellum, but is important in coordination, and then the planning and higher level working memory and cognitive aspects, the creativity in prefrontal cortex, and then amygdala, emotion, and the hippocampus in memory, and the nucleus accumbens, the reward network. All of this is happening without our awareness as we listen to music. So you can see based on that that music really does integrate multiple brain systems, and it extends more than just emotion and the reward network. It's much more complex than that. And that it's thought that the structure of the music itself actually provides a structure to the organisation and the functioning of the networks as music plays out over time. And that temporal flow is really core to that. And that allows good integration and synthesis of those networks within an individual's brain. But then we've seen more recently work that suggests that it might also put our brains in sync with others, and that creates that enhanced social connection. This, we think, underscores the personal and social power of music, why we hang on to it, why we've carried it through with us from an evolutionary perspective. And what it does is it's really a natural brain workout. When we engage in it on a regular basis, it's exercising all of those networks, and it brings benefits to all of those. So if I then engage in another working memory task, I do better at that because I've kind of been exercising that network through my music experience. And this is this concept of experience-dependent neuroplasticity and its transfer effects or benefits for other cognitive functions. So if we give it to kids to do, and they usually love doing it, it creates what we call an enriched early environment to promote their neural and cognitive development, but also their emotional development and their social development. It gives us ways of expressing things. And in providing that enriched environment, it can alter our brain development and the way it's organised. And this is based on this idea that frequently stimulated neurons will establish stronger network connections. And as the child's developing brain grows, well-used connections remain, and those ones that aren't drop away. And that's really the power of shaping the brain. And so when we look over the long term at the brains of musicians who may have started early in life and have played all the way through life, their brains are quite differently organised than non-musicians. And so here's a busy slide, but an important slide. This was a study that I did with a former PhD student, Dawn Merritt, where we took all of those studies that had been published up until this time, and there are even more now, and we mapped the changes that had been reported in all of these different studies onto the brain. So this is a left lateral view of the brain, looking at the brain side on from the left, and looking at the inner, in between the two hemispheres from the left. And this is a right lateral view and a right mesial view or inner view. And what you can see is that the changes encompass so many regions and so many networks that we've spoken about. And in general, those changes are an enlargement of those regions, an enhancement of the connectivity and of the function of those regions. It's not just linked to the grey matter, it's also been shown in the white matter in major tracts that run through the brain. So here's a cross-section through the brain. If you're looking at the brain face on, but you've taken a slice through the middle, this is the corpus callosum, the large bundle of fibres that joins the two hemispheres, and these have shown to be enlarged in musicians and have greater density associated with bimanual coordination, so all of those motor coordinations between the hands, but also the long bundles that traverse from the top through the brain longitudinally have been shown to be altered and enhanced in musicians. So in general, these structural differences are bilateral, and they are enlarged, and that brings functional and behavioural differences and benefits. It brings enhanced information processing, better integration across modalities, and more efficient or focal activation. And longitudinal studies where we start with children who are naive, musically naive, and we either train them in music or they do some other task, like perhaps a drama class or some other activity. We show that the neuroplasticity effects are greatest in the children who are doing the music training, and that their brains show these changes over time. And so music is a good way to induce this experience-dependent neuroplasticity across life. It's not just selective to the young, though. It can also be evident in people, adult novices, who take up music training, and we've certainly looked at singing from this lens. And what appears to be happening, and there's a literature emerging on this, is that music is really priming the brain. It is an inducer of neuroplasticity. This is called meta-neuroplasticity, and it's priming the brain for future learning. Something we haven't talked about is that it can also enhance learning and neuroplasticity in brain-injured individuals. It can enhance their recovery from brain injury. And as I mentioned earlier, that's a talk for another day. But I guess a concluding way of thinking about music and the benefits it brings is that it's a natural way of enhancing our mental health. And it is to music health, to mental health, what sports are to physical health. And so I would encourage all of you to engage in it, because there is a strong scientific basis for that. All right, I might finish there and we can open up and allow some time for questions. And sorry, that is another talk following on.
I was going to say, I thought it might have been some last remarks. Thank you so much. That is absolutely fascinating. We've had a bunch of questions come through. So before I segue back into asking you about some of your talk, Sarah, if people do have questions, please put them in the Q&A function at the bottom of the screen, as well as potentially the chat function. I'm just sort of curating the questions as we go. But that was fantastic, and I'm seeing a lot of people thank you throughout the chat function at the moment, which is excellent. Look, why don't I start? I'll just lean into a little bit about what you were talking about regarding, I guess, conditioning, etc. I did some research, obviously, on what you've been involved in numerous research projects that you've been involved with others over the years. I was particularly interested in where you focused on singing ability and talking about the difference between genetics as opposed to practice. So you've mentioned some positive effects relating to practice and obviously some positive effects relating to mental health by way of integrating music into your life. But you want to talk about the concept of, I guess, genetics being that we're more inclined to be better at music than others who aren't, I guess, inheriting genetics in that way?
Yeah, so this is the $64 million question that we're working on right now, Garry. So one of our studies that kind of led to this, we scanned the brains of singers, and we took everyday singers, so people who are good at singing in the shower, if you like, but they've had no training. We took opera singers from the Melbourne Conservatorium and the Victorian College of the Arts and the like, and then we took self-professed bad singers, people who said they were terrible, and we put them in the scanner and we looked at their brains. And what we found was really interesting. We gave them two tasks. We gave them a language task where they had to generate words starting with particular letters, and this is a good task for the language system. And then we gave them a singing task. And what we found was that our elite or high-level singers had their own unique singing network. It sat alongside the language network, but it was specialised. The professed bad singers were just singing with their language network, right? And perhaps that's why they're not such good singers. And then the group in the middle, the shower singers, were kind of a bit of a hybrid. They had their own network, but it wasn't quite as obvious. And that led us to answer the question, to ask the question, is this a chicken or the egg? You know, did the elite singers start with this network to begin with and they just exercise it more? Or did the training develop it over time? So genes versus environment. And so that led us to launch a big study looking at singing. And we've been looking at singing ability in twins. So identical twins versus non-identical, and the extent to which they show concordance for their pitch accuracy of singing, so how well they hit the note. And what we're suggesting, what we're finding that's being suggested by this, and we're still in the process of writing this up and analysing the final data, is that there is, it looks like, a genetic component. And so that's now led us to launch a study to look at singing in families. And we actually want to attract to this study singing families because we know anecdotally they exist, you know, the Jackson Five, and
Of course.
we've got many examples of those, to look at what are the genes maybe that underpin music ability and in particular singing ability. So this is something that we're just starting to unpick in the scientific literature. There's not a lot on this, but exciting.
Fascinating. I'm going to put in the chat function another link for everyone to have a look at if they'd like to, which is, I guess, a content piece you produced around tone deafness, which I found really sort of fascinating. So people can dive into that one. But what I'll do is head into some questions that people have been asking. I'll start with Nisarg Patil. Being that Nisarg is tuned in all the way from the University of Colorado in Boulder, in the USA.
Yeah.
By way of Pune, India. So thanks for joining us, Nisarg. It's fantastic to have you. Sarah, first of all, thanks for hosting the session. Nisarg would love to know whether there's ways in which music can help motor neuron disease, or ALS, also known as Lou Gehrig's disease. And if yes, how would that help specifically with the disease from your knowledge? Nisarg's referenced some Indian classical music, but I'd be interested to know your thoughts on both treatment and specifically genres if relevant.
Yeah, so I'm not aware of any specific studies looking at motor neuron disease. There may be, but I don't have them at front of mind right now. The rehabilitation literature is still quite sparse. It's focused predominantly on people with strokes, with dementia, with Parkinson's disease. It's focused on kids with autism, and speech difficulties, this kind of thing. What I can say about those is that depending on the nature of the disease, the music can have an impact in different ways. So during the talk, I mentioned, you know, for people with dementia, it's a great activator of their memory system. In people with Parkinson's disease, it's thought to facilitate movement. It provides a rhythmicity and a timing that can assist with some of their motor symptoms. In children with autism, it's thought to be able to help their social cognition and their emotional awareness. So depending on the disorder, the different networks that music activates and brings together can have enhancement. So we might predict that it would have benefits for motor function in people with motor neuron disease, but I don't know of a study that specifically tested that, sorry.
No, fair enough. Got to ask some questions, and
question.
You know, we invite the questions openly and honestly, and it's not every day that people get to, I guess, pose these types of questions in the live format. So we appreciate it. Thank you. So Crystal Tricky had looped in during the conversation, with the recommendation of Oliver Sacks's Musicophilia as a great book on the topic, and I'll put a link in the notes in a second. But Crystal would ask a specific question around the social effect of collaborative drumming versus drumming along to a computer-generated drum track. And whether that requires a physical presence. Obviously, we're talking about a sort of a COVID-19 isolation relevance. Could you talk us through, I guess, that in-person as opposed to that virtual social environment collaboration piece?
Yeah, so there's been some interesting attempts at music over Zoom. I know there's been a couple of choirs who have given it a go, but it was a little bit of a cacophony, right? Everyone was a little bit out of sync, and people found that a little bit discordant and disconcerting socially. It wasn't that good for bonding because everybody was out of sync. So I think singing in big groups over Zoom is a bit challenging. Drumming over Zoom, I don't know. One might think it might be a little bit easier to do. It doesn't have to be spot-on imitation. It can also be coordination between the two, or back and forth, or alternation that can have these social bonding effects. So I guess it's experimenting in the COVID world because we don't have a lot of knowledge of that. But it's not a reason not to do it, right?
Yeah, absolutely. Alice Bark has actually just chimed in, but with one that I was actually going to ask. So fundamentally around the benefits discussed today are attributed to doing, the playing or creation of music personally, as opposed to the experience. So did you want to tell us about, I guess, those distinct elements in relation to the science of music, of course?
Yeah, so a lot of the studies have been done with musicians who play, and it's been thought that it's active engagement in the music that's the core issue. But it can be active listening as well. So there's been some nice studies with stroke patients that show that post-stroke, if on the ward, the person's sitting there and they're listening, say, to a talking book versus they're actively listening to music, versus they're listening to white noise, which is, like the vacuum cleaner sound, that those patients who have been given the music will recover faster, leave hospital sooner, and have all sorts of better physical markers of recovery. So it doesn't just have to be playing. And an area our lab is just now launching into is this experiential component. And this concept, I have a PhD student, Christian Holt, who's looking at this concept of karma mutta, which is, that experience of communal bonding and intense sharing, which I think gives us that belonging to a bigger, universe, being part of something bigger than ourselves, that aesthetic wonderment or awe that we can sometimes have with music experiences. And we're starting to look at what it is about the music that might bring on this karma mutta. And that can be accompanied with chills, but it's more than that. And I don't think we fully know the answer to that, but that's certainly what we're looking at. So thank you for that question, because it's very topical.
Yeah, it's fantastic. I would love to, Stephanie Lacerna's asked a question around whether it's possible for music to have any negative impacts on our brain. So I'd love to lean into that at the moment, since some people have upvoted and will be really curious to know. And then we'll come back to some another few questions relating to, I guess, what's on the horizon for music and music neuroscience.
Sure. So yes, it's a good question, because there are studies, including researchers at Melbourne Uni, Kat McFerrin, who's looked at this in teenagers, the use of music in individuals who might have low mood, and how music can actually be used to take yourself down. So there can be negative ways that we can use music. We know music is this natural method of influencing our mood through its direct path into those mood systems. And traditionally, we would use it, certainly if we think of young kids, we'll put on calming music if we want them to quieten down. If we want to motivate them and spark them up, we'll put on some boppy music. So we're good at using music to regulate our emotions, and it's a very good natural remedy to do that. But it can do harm if we get really into the zone of listening to down music all the time, and our mood is down, and that can actually be counterproductive to us breaking out of that low mood. The other area where it can be problematic is in the addiction literature. So there's been some work by researchers up in Queensland where they look at music either helping you stay clean and off the drug that you've come off, or getting you back on that drug. And people will talk about music that's been associated in memory with using that drug versus music that hasn't, and how if they're trying to override the cravings, they might really need to steer away from music that's associated with that, because that might make it more likely for them to reuse. So yes, there are specific circumstances where using music in that way can be counterproductive.
Fair enough. And thank you for that very much. Yeah, we've got a mixture of questions. They're actually flying through. So thank you all so much. I do apologize if we don't get to all of them. The hour for the talk moves really fast, but we'll guaranteed, I guess, mention some parts at the end of the discussion where people can direct their attention to further in case we don't get to all of them. Katie had asked, and this is predominantly in relation to music education, thank you, she's mentioned, and how can we use these findings to promote music education within Australia, especially in regards to music education advocacy in any way that may already exist or opportunities to do so?
That's a really important question, and one that we've been thinking about a lot under the banner of, under the auspices of Music, Mind and Wellbeing, which Garry mentioned early on, is this broad network of music researchers from multiple perspectives, from the music faculty, through education, through science, psychology and so on. And what we know is that there's inadequate training of music for teachers in schools, so that primary school teachers used to have hundreds of hours that they needed to complete, and now that's been whittled right down to only a few hours as part of their gaining their qualification to teach. And what that means is that the music is, you know, the teacher is not that confident themselves in doing the music activities in the classroom, and so probably less likely to fully engage, and then the children don't get the same level of benefit. We've argued, and we've put multiple submissions to government and the like, that music should be a core discipline. It should be up there with reading, writing and arithmetic, because I hope I've convinced you that when we're doing music, we're using all of those important other cognitive skills that feed into that, and so it will have benefits in addition to the child's emotional and social development. So we would argue it should be core to the curriculum, and that all children should get an opportunity to engage in music. But sadly right now, certainly in Victoria, children will only get involved or get a chance to be involved in music if they've got a good local music teacher. Maybe the schools manage to employ someone additional who comes and teaches instruments to the children or sets up a band. But that's, you know, very variable depending on the area and the resources of the school and the suburb in which the child lives, which I think is a suboptimal situation.
Yes, certainly. I'd love to, and Daniel Yom, thanks for holding tight. We'll get to your question in just 1 second. So thank you. And I know some others are wanting to hear about some future elements, but let me dive into a little bit of a segue into Jai Bishop's question regarding the effects of music on development in youth. So that probably leaps off a little bit what you were just referencing then, that an assumption that adults who take up music at a later stage in their life do not experience the effects to the same extent. However, could we reasonably ascertain that there will be an increase in cognitive ability in adults once they do so at a later stage?
Yeah, so this is this idea of age of onset versus duration of training, right? So if I take training at the age of 4, and I do it for 20 years, what does my brain look like compared to if I start when I'm 20 and I do it for the same length of time? Certainly we know that the brain changes in both groups. So both groups get benefits. But are there particular sensitive periods or windows where I might get maximal neuroplastic effects? And it's thought that yes, there may be. So for certain skills, certainly something like absolute pitch ability, there's thought to be this sensitive window between the ages of about 4 to 6 or 7, where if you're given exposure and the opportunity, then you will acquire this skill. If you try and acquire this skill later in adulthood, it doesn't matter how much you do it, you won't pick it up. So I guess it depends in particular on what you're talking about, but these sensitive windows are important for certain skills, but nonetheless, duration also matters. So it's a bit of a mixture of both.
Yeah, thank you for that. That's perfect. Neuroscience and the future of neuroplasticity. So Daniel, you've thanked Sarah for the talk, which is great, and thanks for chiming in earlier. I've taken a little while to get to it. But Sarah, I'd love to know your thoughts on where the field is headed into the future, either by way of your own research, of course, which you're in the midst of, but also some next big frontiers or trends that you're seeing emerging, potentially with the aid of technology, of course?
Yeah, so is this Daniel Young, my current PhD student? I think it might be. And if it is...
He's planted himself in there. Okay. Thanks, Daniel. Well done.
So he's working on a big study with me right now, which is the genetic angle. And I think, you know, we've just finished reviewing the literature, and there's very few studies here. And this is a really important area for us to pick apart, not just for music per se, but for skill development and expertise development. So music has a lot that it can teach us about how do we maximise our skill development and optimise our performance. And what this is starting to show is that it's not just the specific skills, but it's also things like propensity to practice and engage in practice that has a genetic component to it. And so it's picking apart the mix of those things that are environmentally or experience dependent versus those that are hardwired. And we've got a long way to go because it's complex, right? And we still don't understand the mix of those skills and where we might then best intervene, right? So if I know this component's more amenable to an environmental intervention, then I can really maximise that and get benefits. So this is a more tailored or individualised program of learning and development for children and for people engaging in skill expertise development. So I think that's a big area for the future. Another one, which we haven't really talked about, but I think is very important, is looking at how we really use music in everyday life for our mental health. There's been some studies on this, but we need more in the field studies where we can use what's called ecological momentary assessment, where we can take recordings from people using their devices, their iPhones and the like, where we can look at how they're using music in everyday life and using that to manipulate or manage their emotions and their moods. The benefits and the pitfalls of that, and then for people with certain conditions, how that might help manage their medical or mental health issues. I think that's a big and important growing area too.
Yeah, absolutely. Oh, that's fantastic. I've actually got a couple of questions in this. I might combine them into an emphasis on genre. And just so everyone knows, we're quickly veering towards the end of the time. So if you've got a burning question, throw it in the Q&A. But we're heading towards the end and it goes real fast, as we know. Kevin Chen had asked around the influencing the development of the brain, which is fascinating, of course. And have you observed any differences in development based on the genre that people listen to? But Ken Winkle had also asked around, I guess, a time rhythm. So if it were to be a regular dosing of music over a particular amount of hours per week or per day, what is beneficial? So I guess we're chatting about there's beneficial genres as well as a regular rhythm.
Yeah. So I'll take the second question first about the timing. We've done a study on this in singing. So we took novice adults and we gave them singing lessons, and we wanted to know what's the best way to practice. And we did the neuroscience literature would say that mass practice and instantiation of the skill intensely is the best way to get neural change. Whereas the psychological literature would say that learning happens best when it's peppered with sleep, because we consolidate what we learn and then we build on it the next day. So we did this study where we either gave them distributed learning over time or massed, and we gave them the same amount every week, and we looked at performance. And in the case of singing, what we found was better support for the distributed model of practice, that interspersing it with consolidation and periods of sleep is better for overall performance in the long term. However, it's a good question because not much research has been done on this, and we need to understand models of training and the best way to optimise training. And it could be that it varies for different types of music or instrumental performance. So this is an open and important question. In terms of genre, the kind of general understanding in the field is that you'll get benefits if it's music that you enjoy. So the maximum comes when you listen to your favourite music, or the music that gives you chills, that activates that reward network and empowers you to be motivated, rather than forcing yourself to listen to Mozart. You know, there was this era of the Mozart effect, and it got a lot of media. And babies, for instance, in the US were sent home with a Mozart CD. And it was mandated in the state of Georgia, apparently, that every child that was born had to have a Mozart CD. Now, what we know is that there are benefits of music which are based on mood. So if we're really finding ourselves getting irritable listening to Mozart, then it's probably not going to be having the same impact. And that's the general thinking. There are, however, personality differences that have been looked at in relation to genre. What makes you more likely to like jazz and somebody else to like heavy metal? And it turns out these things map onto personality traits and profiles, and there's been some interesting studies around that. So it's a kind of a complex mix, if you like, of your personality and what activates your mood, as to which genre you should choose for maximal benefit.
Yeah, fantastic. Oh, look, thank you for answering those, both packaged up together. I was, conscious of time, so did want to, try to combine them together. But look, I want to thank everyone for posing questions today. We haven't quite gotten to them all, but nevertheless, I've really appreciated a bunch of people putting in links throughout the talk today, as well as putting a number of questions through to Sarah. So we really, really appreciate it, and thanks for joining us again. Sarah, thank you. Thanks for being with us today, and by extension for the School of Psychological Sciences for being a part of this regular event series. It's fantastic to address a number of the societal factors, and I guess have some fun in hearing from the wider public on some of the research and engaging these questions. It's fantastic.
Oh, thanks for having me. I've been delighted to be part of it, and thank you everyone for all your great questions and for joining in.
Well, my pleasure. We really appreciate having you, and I do appreciate the team's help in having you and others involved. So thanks once again. Look, I'll leave it on this note by letting everyone know that we are recording the event, and we publish it on the Melbourne Connect YouTube, which you can find just simply by Googling it. We'll publish this event by the end of the week, usually after it gets a little bit of editing, and then we'll have another event in the Understanding 2020 series coming up shortly. Some other events on the radar include memory conditioning and more. So we're really excited to continue delivering them, both from a social psychology and a clinical psychology perspective. Melbourne Connect, we have another event tomorrow, so you can find details about that on our Facebook. We're talking about advancing health with technology, an emphasis on medtech and biotech from some leading academics and startup creators. So without further ado, thank you once again, Professor Sarah Wilson. We really appreciate it. And I'll direct everyone's attention, if you want to find out more, to the Twitter handle at PsychUniMelb, or the Melbourne School of Psychological Sciences online, if you simply wanted to Google that. Thanks once again. Stay safe and have a great day.